Yo, what's going on? I'm back with another video. This one, we're going to be reviewing optimization and trapezoidal rules. All right, let's get started. All right, so this first problem is going to be an optimization problem, specifically a minimum. All right, but it says find two positive numbers with a product of 12 and the sum is a minimum. Excuse me. Got a little tongue tie right there. But anyway, for two positive numbers that have a product of 12, it's going to be x times y. All right, and then the sum is a minimum. So x plus y is a minimum. So I'm just going to say that's the sum. So what we first need to do right here is we're going to isolate y. All right, whenever we're looking for a minimum, we isolate y over here. So y equals 12 divided by x. And then we're going to plug that in over here. So we have 12 divided by, I'm sorry, I plugged that into x, my apologies. X plus 12 divided by x equals the sum. All right, that's an S, guys, not a 5, the sum. All right, so what we need to do is integrate this. All right, integrate this. So when we integrate s, well, actually, before we integrate, let's rewrite this. So we have x, well, s equals x plus 12x to the negative 1. So now when we integrate this, we have this is 1, and this is negative 12x to the negative 2. All right. So now we're going to set that equal to 0. So I'm going to go 1 minus, I'm going to go 12 over x squared equals 0. And so I'm going to I want to add 12 over x squared to the other side. And now I'm going to multiply by x squared on both sides. So x squared equals 12. And then we're going to take the square root on both sides and we get x equals square root of 4, square root of 3, or plus or minus 2 radical 3. Now, because they told us it was positive, we only want the positive, so 2 radical 3. All right, 2 radical 3. Now I'm going to plug that in right here. All right, so if I went 2 radical 3 times y equals 12 and divided by 2 radical 3 on both sides, you get y equals 2 radical 3. All right. Now, I had this as a U try right here, man, but you know what? Let me just go ahead and work through it. I think it'd be better that way. All right. So right here it says find two positive numbers whose product is 400. So again, x times y equals 400. All right. And this time it says such that the sum of twice the first, so twice the first, we'll call x the first, and 3 times the second equals a minimum, right? So we need to rewrite this in terms of y. So y equals 400 divided by x, because we divided by x on both sides. And then we substitute that over here. So 2x plus 3 times 400 divided by x. That equals s. So now what I want to do is simplify this real quick. So s equals 2x plus 1200 over x, which we're going to again rewrite as 2x plus 1200 x to the negative 1. Now we integrate this again. Differentiate this again. So you get 2 plus, or actually 2 minus, sorry about that. 1200 x to the negative 2, which we can rewrite as 2x minus 1200 over x squared. All right, we're going to set that equal to 0. So now solving this, let me change colors. Now solving this, we're going to move the negative 1200 over x squared to the other side. So you have 2x minus or equals 1200 divided by x squared. And then I'm going to multiply by x squared on both sides, so that gives me 2x cubed, right? If I multiply by x squared, right? Yeah, 2x cubed equals 1200, and then we're going to divide by 2, so x cubed, equals 600, and then we cube root both sides. All right, and the cube root, and so when we take the cube root on both sides right here, that's going to give us the cube root of 600. Let me see, 8 times 75. I did that because that's a perfect cube. That's 600 right there. So the cube root of 8 is 2. So 2 cube root of 75, 2 cube root of 75 is x. So let's see, 400 here divided by 2 radical 75 gives me 200 over radical 75, which we rationalize as 200 radical 75 over 75. Let me see. Does that reduce 8/3? Yeah, 8/3. 8/3. Radical 75. There we go right there. So that's y. Y and x. Alright. Let's see. Can we make this a decimal? Perhaps. Perhaps. I'll make sure I include instructions on your actual practice activity. Alright, right here. Find the points of the graph of f of x that is closest to 7 and 0.5, round to the nearest, or round your answer to 2 decimal places. So remember, we're going to use d squared equals x2 minus x1 squared plus y2 minus y1. That's the distance formula. All right. So in this case, we have x2 minus our x value of 7 squared plus y2. I'm sorry, y2 is x squared minus y1, which is going to be 1/2. Or was it point? Well, 1/2. I'll roll 1/2 squared. All right. Because remember, guys, right here we can say y equals x squared. So that's y2, y1. All right. So now we need to expand this. So x minus 7 squared gives x minus 7 times x minus 7. Now, that gives us x squared minus 14x plus 49, right? And then right here, when we follow this, x squared times, here, this is x squared minus 1/2 times x squared minus 1/2. So that gives us x to the 4th minus x squared plus 1/4. All right. So we now simplify this. And in doing so, if you see the x squares right here, one positive, one negative is going to cancel out. So I'm left with x to the 4th minus 14x plus 49 point, I'll say 49.25 because 49 plus 1/4 is 0.25. All right. This is our equation. This is what we're going to differentiate. I don't know why I wrote the integration symbol there. So now we're going to differentiate this. And doing so, it gives us 4x cubed minus 14. So we take that, set that equal to 0, add 14 divided by 4. So 14 divided by 4 is going to be 7/2. And then I'm going to cube root both sides. And you get x equals the cube root of 7/2, which neither one of those break down. It also tells us round to the nearest 2 decimal places. So it's gonna give us 1.52 for x. And then I just go back up here when I'm gonna plug it into this original y equals x squared. 1.52 squared. And in doing so we get 2.31. So there's y, there's x. Alright. So that point would be 1.52, 2.31. Alright. Next right here, the closest point, here's another U try. I'm gonna leave that one actually to you guys. But I will flash the answer up here. Alright, so pause it, work on it, work to get this answer right here. Alright, so you should end up with something like this. 4 minus x squared minus 2. Alright, it's going to be y. Remember, y equals 4 minus x squared. So that's y2 minus y1. Right here, you'll see 4 minus 2 is 2. X minus 0 is x, so x squared. Then you got to fold this out right here. You get this. Oh, that should be a plus right there. Sorry about that. So now, simplify this. All right, x squared minus 4x squared is a negative 3x squared. Differentiate this, so 4x cubed minus 6x. Set that equal to 0. Once you set that equal to 0, you can factor out a 2x. All right, so right here 2x equals 0, and x equals plus or minus radical 3 over 2. Now the thing with this one is, let me show you. So we're looking for a minimum, obviously. 0, 4, like here's 0, 2 if you had actual scale. All right, 0, 2 would be here, and 0, 4 would be up here. That's a maximum, so we're not going to use 0. We don't look at that one. We don't look at that one because it's not inside the bell, inside the parabola. So I plug in these two values, radical 3 over 2, and negative radical 3 over 2. I mean, good night. I'm sorry, man, I messed that up. Negative square root of 3 over 2. There we go. And when we plug, you get 5 halves and 5 halves because they're both plugging the negative or a positive is still going to be the same thing, okay? Once you square it, so those are our 2 points right there, all right? Now, trapezoidal rule, all right? The first thing you need to do is find delta x, all right? So remember, delta x is going to be b minus a divided by n, and n in this case is 8. So that's 6 over 8, which is 3/4. All right. So now we need to take our number line. All right. And guys, yeah, you can graph it. All right. I recommend you graph it, but I'm trying to keep this kind of short. So I'm going to start at 3. I'm just going to add delta x to it. I need all these x values. I need all these x values. I need all of them. All right. So 3 plus 1/3 is 3 plus 3/4. Sorry. There's 3 point. Hold on. Let's leave all this as a fraction. So 15 over 4. Oh, let me make this smaller because I need more room to write since I broke it up 8 times. All right. 15 over 4. And then if I add 3/4 again, 9 halves. And then I add 3/4 again, 21/4. And then I add 3/4 again. I'm just going to keep doing this, man, until I get literally my next value. All right, which I'm trying to get 9. I'm trying to get B. So I keep doing that. 27 over 4. Do it again. 15 halves. Do it again. 33/4. And one more time, and you get 9. So that's where we were trying to go, 9. All right, so give me a second. Let me clean this up. All right, so those are all the x values we need to test when we put this equation into our calculator. So I want to go to my calculator real quick so you can see this get done. All right, and I'm going to place that equation into the calculator like so. All right, so we have 20 minus x squared, and then we're going to hit graph, and it's going to graph it like so. All right, now we want to go second trace to our values right here. All right, so let me clear out list 1 real quick. Well, let me do it. All right, hold on. Now we're literally going to plug in all those x values we had. So we had 3. We started with 3. Then we had boom, 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 boom. 15 over 4. Alright, then we had 9 over 4, 9 halves, excuse me, 9 halves. Alright, and then we had 21 divided by 4. Oh, don't want that, 21 divided by 4. And then we had 6. And then 27 divided by 4. And then 15 divided by 2. And then 33 divided by 4. And then finally 9. Alright, so these are all our y values right here, our heights. So take a good look at that. Take a picture if you need to, whatever. So when you put these in a second, they all make sense. Alright. So when I went back over here to the graph, alright, remember now we're going to use this rule right here where it says b minus a over 2n, okay, for our initial value right here. So we're going to go 9 minus 3 over 2 times 8 gives us 6 over 16, which is 3/8. So we have 3/8 times the initial value was 11. All right, plus 2 times 5.9375 plus 2 times negative 0.25 plus 2 times, and guys, by the way, remember all these middle values are going to be multiplied by 2. So 2 times negative 7.563 plus 2 times negative 16 plus 2 times negative 25.56 plus 2 times 36.25. All right, so on and so forth. All right, so these are all the values we had, and you literally just punch all this in. All right, you go ahead and add all that up. All right, when we do that, it gives a negative 114.56. All right, right there. Oh, I don't know why I put do not use your calculator right here. Man, use your calculator, man. I just mean don't. Make sure you use the trapezoidal rule. Don't just integrate it. But anyway, if you did that one, you'd end up with negative 114. If you did do your calculator. All right, now for this one right here, this is a you try. I'm gonna let you try this one, but I'm gonna just put the answer up here, okay? So here our approximation is going to be 176. All right, we do that one. So trapezoidal rule will give you 176. If you did the exact, you'd get like 170.66 or something like that. Okay. Well, hey, this concludes this video, man. It's under 20 minutes, so I'm happy about it. There's a practice worksheet, man, and good luck. Make sure you put that in the Dropbox and join us at 1, where myself and Mr. Jacob Ozzie will be lecturing. If you need extra help, jump on, ask questions, or just say hello. Catch you later.